Hello, self-isolating sixth graders. Let's get back into these little video lessons. We're going to start with Chapter 3, Lesson 2, finally. And these lessons are all going to be a little bit shorter, and I can present it usually in just one session. So let's begin. Chapter 3, Lesson 2 is about how we classify rocks. That means we have to know what a rock is. The definition that we are going to be working with is on your screen right there. A rock is a mixture of minerals, rock fragments, organic matter, volcanic glass, and other natural materials. So right away you can see that this definition compared to the mineral definition is way more loosey-goosey. Um, it's going to encompass a lot more and be more generous with what's allowed to be a rock versus what's allowed to be a mineral. So let's take a quick look at the definition of a mineral. Remember that it has four parts, and what the corresponding definition would be for a rock. So minerals have to be naturally occurring. That means that they occur in nature. They are not made by humans or anything like that. They're not made in a lab. The same is going to be true for rocks. This is going to be the one thing where the rocks and minerals actually have something in common as far as their definition goes. Both of them have to occur in nature. Now, let's look at differences. Minerals absolutely need to be inorganic, and that means that they cannot be made by an organism. So they have to occur in nature, but not be made by anything living. Rocks, on the other hand, can be inorganic. There are plenty of rocks that occur naturally, and they're not made by an organism. But there are some rocks that are made by organisms, or even made out of organisms. Or a rock can actually be a mixture of both. A rock can have some parts of it be organic and some parts of it be inorganic. Like I said, way more loosey goosey. A mineral has to have a definite chemical composition. That means that it's got one formula, and that's the only way to make that exact mineral. And that same atom or molecule is just repeated over and over and over and over again. You can't have any other kind of mineral, or I'm sorry, any other kind of molecule in a mineral. Rocks, on the other hand, because they are mixtures of minerals, means that they're are going to have many chemical compositions all kind of mashed together. They are going to be a mixture of many types of molecules. And then finally, minerals have to have an orderly arrangement of atoms. They have a repeating pattern of molecules, and we've also been throwing the word crystal around for that. So each mineral has a preferred crystal structure that it will always make. Rocks, because they are mixtures of many different types of minerals, and each mineral has a crystal structure that it prefers, are going to have many crystal structures all kind of hanging out next to each other. So in one rock, you can have several crystal structures all kind of being neighbors with each other. So let's look at some visual representations of this. So here we have a rock. Um, this diagram very nicely shows you the different minerals that can be in one rock. So all of the black specks that you kind of see scattered throughout this entire rock come from a mineral called hornblende. There are tiny little bits of rock that are very reflective, and these are the micas. These are kind of golden and sparkly. They're nice. Feldspar are your whites and pinks that you see scattered throughout. And then quartz are going to be kind of your glassy grains that are kind of scattered throughout. So in just one rock, you've got one, two, three, at least four different minerals. Now, over here off to the side, I looked up the crystal structures for each of these. So all the little bits of quartz are going to be in a what's called a trigonal crystal structure. All of the little black bits are going to have a monoclinic crystal structure. Mica actually also uses the monoclinic, so all the little gold specks are going to be monoclinic in their crystal structure. But all of the pinks are going to be in a triclinic crystal structure. So in one rock, we have a lot of different crystal structures all kind of next to each other. So this is an impure substance. It's made up of a lot of different minerals, and it's going to have a lot of different crystal structures and of course a lot of different chemical compositions, but we're going to get to that on the next slide. So my point is, rocks are mixtures of all kinds of things mashed together. I also looked up the chemical formula or definite chemical composition of these minerals. So the only way to get quartz is to have one atom of silicon and two atoms of oxygen as one compound molecule. SiO2 is the definite chemical composition of quartz. Every little speck of quartz that is scattered throughout this rock has this chemical formula. It's the only way to get quartz. All of the black bits, the hornblends, they have a much more complicated chemical formula. So it looks like two calciums, there's a magnesium, an iron, and aluminum, and then there's going to be 5 of each of those. And then aluminum silicons are going to have 8, 22 oxygens, and then two little branches of OH. So they are very, very complicated. Mica, a little bit less complicated. And then feldspar looks like sodium, aluminum, 3 silicons, and 8 oxygens in each one of those molecules. So in one rock, you've got several different molecules all kind of mashed together in one substance. So rocks are mixtures. All right, we're going to look at 3 basic kinds of rocks. And within each one of those, we are going to look at subcategories. So to get the subcategories in each one of the following lessons, you are going to be looking at the mineral composition, the color, the texture, and the origin. And that's going to kind of help us give us subcategories for each of the 3 main categories. So as we look at the 3 main categories, we are going to be looking at mineral composition, what minerals are in these main categories, and that's going to help us kind of start to break down subcategories. So the types of minerals found in a rock are going to help us classify rocks. Minerals are kind of grouped by their chemical composition. So we have a group of minerals called the silicates, and a group of minerals called the oxides, and a group of minerals called the carbonates. And how many silicates versus how many oxides versus how many carbonates that are in a rock are going to help us start to break it down into subcategories. Now, this looks way, way complicated, and we won't have to use this in 6th grade, but I wanted to give you an idea of what geologists actually use. So let's take a look at silica content. These are your silicates. So the higher the silicate content of a rock, the more over here that a rock is going to end up being. If it's got a lot of metals like iron and magnesium, that's going to kind of shift it down to this end. So muscovite, the micas, they are over here, which means that they have a lot of silicas and not a lot of irons, or a lot of metals in their chemical structure. Quartz was SiO2. There's no minerals in that. So that's going to give us different generic terms for subcategories like felsic and mafic. Anyway, my point is that when we go through our 3 main types of rocks, we're going to be looking at what kinds of minerals are in them, and that's going to help us break into subcategories. All right. When we looked at minerals, we were not allowed to use color. And why not? Well, if you remember, one mineral can come in a wide variety of colors. Something like topaz comes in like 7 or 8 different colors. So we had to use streak instead of color. So for minerals, we never used color to identify the mineral. We can't look at a pink mineral and say, oh, it's, and then name it. Well, with rocks, That's one of the very first things we get to do. We are going to look at the color, the apparent color of a rock, and that's going to help us identify it. And that's because rocks are a mixture of several different minerals. So, um, if something is very, very light colored, well, silicas tend to be very light colored. So we can say, oh, it's a very light colored rock. So that means it's got a lot of silicas in, and that's going to help us classify the rock. Something that's very dark colored is very low in silica, and it's going to have a lot of metals in it. And so that's going to give us a subcategory or classification. So as we go through our three main categories of rocks, we're going to be one of the very first things we get to do is look at its color and help. That's going to help us break it into a certain category. It's going to be awesome. All right. The third thing that we're going to look at in each of the main types of rocks is what's called their texture. Each individual mineral within a rock is called a grain. So let me scoot way back here. Okay, each one of these tiny little specks of a mineral is called a mineral grain. So here's a mineral grain of hornblende. Here's another mineral grain of hornblende. Each one of these tiny little black dots is a mineral grain of hornblende. All of the little pinks that you see scattered around are mineral grains of feldspar. So here's a feldspar grain, here's a feldspar grain, here's a feldspar grain. Everywhere that you see these pink dots, those are feldspar grains. The darker golden sparkling ones, those are your mica. So there's a mica grain, there's a mica grain, there's a mica grain. All right, you get the idea. So flash forward. Okay, so the types of grains, which we're going to be looking at the size of the grain, the shape of the grain, the patterns of the grains, these are going to help us break rocks into groups. So here we have two rocks that are actually made out of the exact same types of minerals. This rock here and this rock here have the same mineral composition, but they were formed in different ways in different locations, and that gave them very different textures. The grains on this picture on the left are very, very large. The grains over here are much, much smaller. You need magnification to see individual grains. If you looked at this rock under magnification, magnified would actually look something more like this. But without magnification, they look very different. So this has what's called a coarse grain texture, and this is what's called a fine grain texture. And we will see better examples of these as we go through our three main kinds of rocks. And then finally, where these rocks were made, even within a major category, is going to help us classify them. So the word origin means where something comes from, where it originates. We're going to be looking at the origins for our three main kinds of rock. So throughout this lesson, I've been talking about, and I've been referring to the three main kinds of rock that we're going to be looking at. Well, they're right here: igneous, sedimentary, and metamorphic. When we look at igneous rocks, which are rocks formed when magma or lava solidifies, we're going to be looking at the texture of igneous rocks, the color of the igneous rocks, the mineral composition of the igneous rocks, and then finally the sub-origin of these igneous rocks, whether it came from magma or lava. And when we look at igneous rocks, we're going to look at those four criteria, and that's going to give us subcategories of igneous rocks. Then, when we look at sedimentary rocks, which are rocks formed by layers of sand, silt, clay, or gravel, and they are cemented and compacted together, when we look at that, we will be looking at the textures of the sedimentary rocks, the origins of the sedimentary rocks, the color of the sedimentary rocks, and the mineral composition of the sedimentary rocks. And that's going to help us break sedimentary rocks down into smaller categories. And then finally, metamorphic rocks form when heat, pressure, or fluid act on igneous, sedimentary, or other metamorphic rock, and that's going to change their form, composition, or both. And we will look at the four criteria, and That's going to give us subcategories of metamorphic rock. All right. So for now, all you need to know, let me zoom back here, is that when we classify rocks, we are going to be looking at mineral composition, color, texture, and origin. All right. That's it for today. Your assignment is to answer the online questions in the Google form. Do not ask me about bookwork. I don't want to hear anything about bookwork. Don't even ask like when is bookwork going to be assigned? Don't ask me anything about bookwork. You don't have bookwork. Just do the online questions in the Google form like we did for distance learning days 1 through 10. All right. Whew. Bye bye.